know what? Apologies. I'll explain it again, and I'll cut this part of the video out once it's live in the editor. So I thought we'll talk about the API, Assistance API memory management first, because I thought it was complex enough. It's worth another look. And then secondly, we'll take a look at, I accidentally closed it, Unstructured API, which actually allows you to deal with HTML, PDF, CSV, PNG, PPTX, and many more documents. And you just call an API. They give you a free API key. And then you send in a PDF, and it sends you really nicely organized JSON objects. It actually splits it up for you too. So we'll take a look at that, and then I thought we'll also take a look at the Everything GPT API course, why that's useful, and also take another look at Instructor. So let's begin. Maybe let's start with the memory one, because I didn't feel like I provided many examples here. So let's just start with the basic memory management. Let's set this to, let's say, 20, is very simple. If we run this, we can engage with the Assistant API in a chat loop-like conversation. Currently, I'm retrieving an assistant I've created, but you can create a new assistant, and you can modify your assistant in the playground. We'll take a look at that too. And you can actually have your tools here, right? You can have your functions here. You can have your code interpreter, retriever. It shouldn't affect this part where we're dealing with the management of the messages because the retriever and the code interpreter steps takes place in the run. So you don't have, like, the messages is separate. So that's actually kind of nice. If I go to the platform real quick, if I go to my assistant, this is the one I'm using. See here, I believe this one. And if you go to edit, here is your assistant ID. It's also visible here, but you can actually turn on code interpreter. It's actually on. You can turn on retriever, add files. You can add functions. As long as you're calling this ID, and if you update it here, it'll reflect in the code as well, right, in your program. But so what I have is it automatically saves all messages to a JSON file. It's currently loaded, but it's going to refresh. If I were to say hi there, we're going to see this message is updating. Oh, maybe this one doesn't save it. No, it does. Let me see. Oh, yeah, it just didn't. Yeah. Hi there, see? And then the response from the assistant. And if I were to say, how are you? It's going to respond again. And because we set the memory limit to 20 words, it's just going to start dropping earlier messages, but something interesting is going to happen there. Okay, so unfortunately, I'll have to drag it again. Yeah, as you can see, assistant user is me. So we have dropped the conversation. If I would say, what is 3 plus 3? So there's only one message now. And if we take a look at it again, see, now we have a single message with earlier messages dropped. User said, what is 3 plus 3? Assistant said 3 plus 3 equals 6. So this creates a new thread, but to be able to do that, again, I'll explain it with the Xcolor Draw. So the thread includes all the messages, right? So all the messages go into this thread as user and assistant, and they stay there. You can't delete messages from the thread. Okay, so therefore you can't modify this thread. So to do this, what we're doing, you need to create a new thread. Okay, but when you create a new thread, you cannot just create all the messages appropriately. For example, imagine you have this thread, and then you want to get all the messages out of it, and then drop some of them, and then put it into a new thread, kind of like this. You can't do that because the API currently doesn't allow for you to create roles for assistants. So there's a problem. So what you have to do is, let's say you had these messages, but then these two were exceeding your max word limit. So what we're doing here is we're creating a loop, reading all these messages. We create a user message, a new user message, only a user message, and then we're putting all of these in there as the memory, right? All of them. And this is what this reflects right here. This is that user message. Maybe see role is user, and because it is like this, because all the messages go in there, and even though we say this is what the user said, this is what the assistant said, this is what the user said. Let me pull this to the side. So we are doing this here. As you can see, user said this, assistant said this, but because it's all in a user role, Assistance API has difficulty understanding that. And some strange stuff happened. For example, after it's in the user message, if I were to ask, like, what have we talked about so far? It should answer correctly now. Let's say. Just one moment. So what happened in the past is that it literally, it knows these things, but it says we didn't talk about these things, okay? That's why I'm inserting this assistant is you, user is me. Actually, sometimes with this, it still does that, and I made a modification in the other files, which we might edit here. So it says, so far we had the following exchange. You ask me, say, what is 3 plus 3? So it remembers from this. But sometimes it says, we did not talk about what is 3 plus 3. It says, you know, and I didn't answer you as 3 plus 3 is 6. So that was like really strange. And I'm like, what's going on here? Am I doing something silly? Am I imagining things? And then I realized that, oh, because I'm inserting this into another user message in a separate thread, but it doesn't see it as a conversation it had because it doesn't have this structured, like user said this, like with the role user, role assistant breaking up of the messages. So it was almost like it knows these things because it's there, but it says, yeah, but we didn't talk about this, it would say, right? So therefore, I actually fixed it in the 4th and 5th file. And if you like, let's just go jump to that. But maybe quickly before we jump, I'll just say what's happening here. We initiate a secondary memory, and when we are engaging in the memory consolidation process, we loop over all the messages and we append them to a secondary memory. And with this, we create a new thread, and we add the user memory message. So we create a list and turn it into a string with like a new line after each element, and then we create a new thread and create a new message as the role user. This is how we are able to get this, and that's it. And let me find. Say I initiate the secondary memory as assistant is you, user is me. So that's why we add this first, right? This is the first element, and then user message is the second element, assistant is the third element. And when we are joining it with the new line, it just adds it as a new line. That's why you see the new line characters here. And then we just create a new thread. So each time we hit the max word limit, it creates a new thread with the new accumulated messages. Yeah, you can reference message ID, but I don't know if it would be useful here. Usually message ID is used when you are retrieving the thread. For example, here, this is the way to retrieve the thread, client.beta threads messages.list, and you input a thread ID. So this is a lot of cool parameters. See, I just control clicked on the list and went in there, and it actually accepts before and after. And these can be message IDs. So when you're retrieving your messages, you can say after, right? You can put an after message ID. How does it know what this message is? Because we created it here, right? This is the user input. So we take user input, create a message in that thread called with user input. So now we have this message object. And when you're retrieving the thread, you can insert it as the after ID. Okay, and then it'll retrieve, because instead of returning all the messages, it'll only retrieve the messages after that ID. Since that was the user message that you sent, then it will naturally retrieve the next one, which is the assistant's response. Okay, so this is just simple trimming, message trimming, right? This works. It works by creating new threads each time with a new message. If you're obviously you don't want to have max words at 220, you probably want to have several thousand. You can go up to almost 100,000. I'll mention why that is real quick. If you actually go to OpenAI Tokenizer, somebody actually asked me, I believe either on YouTube or Discord, like why did I go with word count and not tokenizer? Number one, tokenizer just makes the code a little bit more complex, and tokenizer has a bunch of dependencies which you don't have, like have to install, like it requires matplotlib. I don't know if that changed. And I just didn't want to deal with all that. But here is the tokenizer, which can give us, if I were to type this sentence have 5 words, 1, 2, 3, 4, 5, see? 5 words, 5 tokens. And now it has 10 words. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. There's 11 words, and it's 13 tokens corresponds to 11 words, and because the dot and the space corresponded to a different token. So there's a very close match between the words and tokens. There will be more tokens than words. But you can, I thought word would be just enough. That's why, pretty much. It's a bit of a lazy approach, but if you set this to 2000, then let's run this again. Then it's just going to keep building. Maybe not 2000, but let's say 50. And this is just going to run normally in a single thread until that message. Hi there. How are you? Let me just type in some messages. What is the +3? And it's going to create a normal, assistant. Oh, I didn't run it properly. Hi there. How are you? What is 3 + 3? It's going to create a normal messages until it hits that limit. Say hi there, hello, and it's going to go on like that. And then eventually when it hits that 50, it's going to summarize it. Yeah. So if this were to be set to, let's say, 500, then after 500, it'll continually create a new thread. So let's just move on to the next one. There was a question in previous memory. You were using TikTok, and mixed word count, because like I explained, there's not that huge of a difference between the word count and the token count recently. Almost every word corresponds to a token now, except the dot and the spaces sometimes have a token. So I thought word should be enough. Like it's a rough estimate, but just remember that you're going to have more tokens than words that you have. If we have 100 words, it's probably going to be 120 tokens or something like that. So if you have 1,000 tokens, you can maybe have 1,300 or 1,300, 1,400 tokens, something like that. So you can just roughly go with that. Sorry, maybe I already explained that. So let's set this to 500. So the next one was a bit, different because the reason is I wasn't sure how to do this right at first. That's why I had the 5th implementation. So let's say we have a memory limit, whatever limit we have, right? So we're gonna start having our messages, and these messages are gonna be in our original thread. They're gonna come here, and at some point we're gonna hit this max words token limit, like right, just like that. And then what happens after that? Originally we were just cutting the message off. Then I thought, well, let's summarize. Instead of cutting these out, I thought let's summarize them. So essentially that's what happens. Instead of trimming the messages, the additional messages that go beyond the max word limit get summarized. But then a lot of interesting complications happen, because where do you put these summarizations versus not, and things like that? Do you count the summary against the word limit? I decided not to. So in this implementation, which is the link to these are in the description, they're on my Patreon. And on the fourth file, I'm not counting, as a matter of fact, the summary against it. You can maybe modify it if you like, because I thought that would kind of be defeating the purpose. So once these fill up, additional messages get summarized, and then after that, you're gonna hit the limit almost every turn. So you're gonna continually summarize them. And let's say like they're gonna be in the summary. Let's just do this. So this is gonna be summary, and then the summary is not counted towards the max word limit. And because you already have messages, you also have regular messages in the regular assistance structure, user assistant. And every time you send a message, you're probably going to exceed this. So you're going to perform summarization. Currently, the summarization model is set to GPT-4, but you can change that. So, I mean, this is just how I thought it should work. But, again, feel free to change it. That's why I had to keep track of a lot of stuff. Like, you pop the summary, for example, only in the first iteration of running and counting the max words and stuff like that. That's why I had to keep track of multiple, like memory consolidation. So each turn we were checking if we're consolidating memory, but we also have to check if the consolidation process in the entire history has begun or not. Because originally we only have a single thread, and once we enter the memory consolidation phase, now we're always dealing with a summary, so we have to deal separately with the summary. That's why. Let me run this so we can just see it in action. Maybe let's change this to 50. Okay, let's go with 50. It should be a better demonstration of it. So again, hi there, right? And then how are you? And these are gonna be entered in here like regular messages. Let's see if this is gonna update this time. It's sad that this is not auto-updating, but yeah, see, thank you for asking. So as you can see, we have multiple messages now. What is 3 plus 3? There we go. See, we entered memory consolidation. Therefore, now if you look here, now we have a summary. And we have regular conversation. So this is the trick here. So I'm adding two messages into the new thread. One is a user message as the summary, and the other one is the reconfigured or restructured continuous conversation. Again, it has the assistant is you, user is me, and then the rest of the messages. However, here we have a summary, and I guess this is where the problem was happening. Maybe I misspoken earlier when I said that it would know the summary, but it would say, okay, yeah, but we didn't talk about it. You didn't ask, the user didn't greet the assistant. So it would literally know these things, but it would deny having had this conversation. That's why when in the summarization call, I instructed that summarize the given text, always respond as, imagine we had the summary of a conversation so far. So this is directly returned from GPT. Maybe this is not the best approach, right? Because what if it doesn't return it? What if you're using 3.5? It might sometimes not put it this way, and then you can run into those issues. So you can just add this yourself programmatically in the beginning of every summary. But so for all the testing I've done, this actually worked well. So I kept it that way. So if we were to continue this conversation, it's just going to get summarized. Like, what is Ramanujan known for? This might be a long reply. By the way, I do want to mention something exciting. As you know, I have the website CodeHive. You can visit it at codehive.app. Make sure to put the www in it. I'm still trying to figure out with the domain provider how to fix that. But you can find, quick chat apps powered by GPT. But I built a new app, actually. Check this out. It's a polling app. It uses AI people to poll stuff. You can ask any question, add options, and get a poll. And at the end, you actually get a summary of the reasoning why people voted the way they did. They are AI people. That's why it's called askaipeople.com. Again, do put the www in front of it, please. Otherwise, you're going to get an error. www.askaipeople. I should actually put it in the description. So let me know what you think. I think this is a fun one. I think it's also useful. I used to use something like this to pick the YouTube titles and stuff. Anyway, so here we have a long message. It should have been summarized. Yeah, see, so we have a single message. We have this message, but it's empty. We are automatically creating that, right? But since we easily surpassed the 50, it says the user inquired about assistance well-being, asked a basic arithmetic question, and then Srinivas Ramanujan. So it summarized the whole thing. So this really works, and because we're saying, imagine we had this summary of a conversation, it actually treats it as a conversation. Yeah, will it give an accurate summary of what it knows? That depends. For example, here it says that user asked a basic arithmetic question. That's accurate, but it didn't say what the question was. So therefore, that part is lost. That's why I want to do more experiments. So this is kind of like a basic approach. I did say keep all important information. It's usually very good with keeping track of the sequence of events, although I didn't test it with thousands of words or anything like that. It should keep the general tendency of the conversation intact. Plus, you still have the regular conversation, right? Only after a certain amount, the summarization occurs, and then you're hoping that the conversation probably had moved on. Like if you do 2,000, and by the time you need to access something that you said 2,000 words ago, chances are maybe or 20,000. Hopefully you don't need, but long story short, it's not an exact summary, right? It's a summary nevertheless. That's why I want to experiment with different forms of summarization, which I'm going to be doing, both with Assistance API, but probably with the normal the GPT call API. But let's quickly see what happens here. So this function summarizes, this function just waits on the run. We retrieve the assistant or create a new one. So this is when we enter the true loop, we take user input, create a message, then run, and wait on the run. So this is going to happen every time. There's nothing exciting happening here because this is the main loop. I'm just trying to find a place. We save the run steps and then we retrieve the messages. So this is where interesting stuff starts happening. Let me put a breakpoint here and then we'll run it with the debugger so we can see what's going on like one by one. Okay. Again, we'll start with hi there. So when we enter the message, let's remove that. We create a message, and then our next stop is right here. Message is being generated. Once the run is completed, we retrieve all messages. Plus, we retrieve the assistant's response. This is what we talked about earlier. So we retrieve all messages so that we can list them right into the secondary memory. And we retrieve the assistant response as the last message. And we do that by pointing after. And we also ordered in ascending order because the normal order of events in Assistance API is descending. And then after the message ID, which is the last message we have sent, which is the user input right here. That's how we are able to retrieve the last message plus all messages. Okay, and then we're going to loop over, right? And look, see, we are going to add to the secondary memory. We've done it one time. Now the second time, so user said hi there, assistant said hello. So this part is done. So now we have a secondary memory. We've extracted the original messages from that. And then did consolidation begin? No. So why did we need this, right? Because if consolidation had began, so we entered the consolidation, but we haven't completed the consolidation, the first consolidation process. Once we complete it, we set consolidation began to true, and it will always remain like that. Because when we are counting the tokens, next time around, when we're consolidating, we are not going to count the entire contents of the secondary memory. We are going to skip the first element because the first element is the summary. That's why we're keeping track of this. And then in the second time around, we're going to have another list which is not going to include the summary, so that when we count all the words that are in the messages history, we are excluding the summaries. And then we initialize a new list, which is called memories to be summarized. And then here we check. See, we check the length of the entire secondary memory if consolidation hasn't begun. If not, consolidation began. Otherwise, we check the messages to count. The only difference between the secondary memory and messages to count. Like, I should still learn to. Thank you very much, by the way. I appreciate it. In the chat, thank you. The only difference between secondary memory and messages to count is the summary. Okay, see, this secondary memory includes all messages. Messages to count includes not the summary, excluding the summary. So here, when we're checking, if consolidation hasn't began, we check the entire. Yeah, you get the idea. And we skip because we skip this whole while loop because none of these conditions are satisfied. So we are not consolidating. So we're going to skip this one too, I believe. Yeah. Then we simply are going to, I think we're redundantly retrieving it again. We are just continuing. Nothing happened. This is just regular assistant stuff going on. We just write the messages, display the message, and go on. What did we say? Oh my God, 20,000. We'll never reach it. Let me change it to 20. And let's run this again. We'll do it quick. Oh, we won't measure intelligence. You know, I think that's a very broad question. We should definitely do one though. Maybe, you know, I mean, maybe like how well it summarizes. I mean, we want, obviously, there's no way that I can think of how to measure the intelligence, but we can definitely measure how well it's summarizing and stuff like that. Not in this video, but hi there. I'm going to skip the first part after we receive the message. Let's do that. And then let's ask simpler questions. So what is 3 plus 3? So I'm skipping this. I believe you get this part. I'm skipping it. Oh, we have entered the consolidation. My mistake. I put the check mark in the breakpoint in the wrong spot. Hi there. Let's just ask how are you. We should definitely trigger it. Okay, we skipped the first one, and in the second one, we'll see what's going on. Okay, so we initialize memory to be summarized, and then we check for the length, and yes, we are exceeding, secondary memory is exceeding max words, which is currently at 20. And then because it's not consolidation began yet, we print there's currently 47 words. We set memory consolidation to true. Now here, this is another interesting one, pop summary. Because so this is the mind-bending part of it. Essentially, because I'm keeping track of two different messages and I need to use them in the appropriate time. We want to pop the summary out of it for certain processes. Memory to be summarized. Oh, sorry. Let's see what happens. I actually kind of. So we pop. So what happens essentially in this part is we pop from the secondary memory and add to the memory to be summarized. Say here we added hi there. Is consolidation began? No. We entered this loop again. We print. Again, we grab. Oh, that's right. Because in the first one, we don't have a summary yet. Sorry. In the first time we enter this loop, we don't have a summary. And because we don't have a summary, we are only popping it one time. Okay. But if we do have a summary, we do want to pop the summary first and then the next message. That's why we have a Boolean to keep track of this. So when we first consolidate, we don't have a summary, so we just get the messages one by one. But the next time around we enter this loop, we're going to have a summary. So we first have to grab the summary and then grab the next message, but we only have to do this one time. If we need to continue to grab messages for one reason or another, then we need to continue picking one message at a time. So that's what I tried to accomplish with this pop summary here, and that's what happens. Okay, and the next one. And lastly, we do it again. So we've added 4 messages. See, the greeting and the how are you. And we're done. We are in the memory consolidation. So we enter here. Consolidation began true. Once we set this to true, this will remain true for the rest of it. And then we make this call to get this summarized. Let's take a look at this again. Summarize the given context. Always respond as imagine we had the summary of a conversation so far. Remember, this was necessary to make sure that assistant realizes that this was a conversation that had happened. And then now we're getting the summary. Okay, and now we are just going to join the secondary memory. If we had anything here, we don't, but we are going to initialize it with assistance as users may anyway. And then we create a new thread. And then we just insert everything into the thread. Yeah, sorry. Yes, we have the summary of memory and we have the rest of the messages. So we create a thread and we insert the summary first and then the rest of the messages second. And after we do that, we set memory consolidation to false because now we're done with it. We're just going to do this every time, except the consolidation began will remain true. And then we just write them down. So if you look at the messages, should see what's happening. So this is the first message we added, which is the summary, plus the rest of the conversation if we had one. So this is how it works. I don't know if this could have been simpler, but because of the fact that I didn't want summary to be included in the max word count, because GPT-4 has a way of always condensing the summaries more and more, I didn't think that would be a big deal. So that's why I left it out. But then I thought, well, this is going to make a call to summary almost every time, because now we have the summary plus this one is going to have the rest of the conversation. So the max memory, the secondary memory is always going to be filled up almost close to the max word. So you will be summarizing each time with this approach. That's why I created the next one, which might be more useful depending on your use case, which just essentially just summarizes every time these messages enter, and then as a new message comes in. But how it works is, right, we have all these messages coming in. As soon as your max words quota fills up, it grabs all the messages and summarizes them, all of them, right? And then it creates a summary. Now you have this one summary, which is smaller, much smaller. So that's all you have now, right? Just the summary. But as the new messages enter, now you can actually have many more messages here. In this case, we are keeping track of the count of the summary. So we have the summary plus many more messages. It takes a while until you hit the max word limit again. And when you hit it again, then we get all three of these summarized. And when they are summarized, then we have a larger summary, right? The summary grows, but then we can still accept messages. And when we reach the limit again we summarize. So summary gradually grows, but you're not summarizing at every turn. So I thought this might be more useful. Yeah, and it's also simpler. This is very self-explanatory, really. Essentially, we're only keeping track of the secondary memory. Say we update the secondary memory, we check. If secondary is memory overflow, method just returns the length of the secondary memory, matching if it's more than the max words. If this condition is met, then we consolidate memory, essentially just deal with the structuring of all those, and then call the summary and create a new thread and then send a message. That's it. So this is much more simpler. So this is how it all works, right? So essentially, we're doing everything we do in the advanced memory, but in a much more simpler way. So yeah, if you like this approach, the files are available at Patreon. Link is in the description. Feel free to use it, modify it as you like. I'll be doing more memory experiments. Like I said, this was the beginning. Implementing it into Assistance API was the difficult part. But this should be much easier and almost funner dealing with the regular GPT API. Again, like I said, this will work with code interpreter, retrieval, and your functions, because the message list in the thread doesn't include any details about that. You can also separately keep track of your files and stuff like that. Those parts really don't have much to do with the messages list. Again, like I said, if you go to your assistants, once you create an assistant, you can find your ID. You can turn on and off your code interpreter retrieval. Whatever you do here, as long as you have your ID, will reflect in your code as well. So that's about it. Let me see if there was any questions. Dennis. Yeah, we said we'll try to talk about that, but in terms of like summary performance and things like that in the future. So this is all I had to say about the memory management. I do want to mention we are saving the run steps too. For example, let's do one more thing then. Because this model actually has code interpreter turned on, and its next word is 70. So if I were to ask what is 5 times 5, let's see what it does. Sometimes it actually calls the code interpreter, and you can actually observe if it did or not in the run steps. Okay, see, we got an answer. Let's look at the run steps. What happened? Yeah, see, it called code interpreter. So the whole time when we were asking math questions, it could have been calling code interpreter, but our messages is uninterrupted. Because after code interpreter does all of its stuff, it just returns the answer to you. So that's what I mean by messages remaining unaffected, even though it just called code interpreter and it's turned on. So yeah, so this works with all your other tools. All right, so next up is going to be the unstructured API. This is really useful. Unstructured API is going to extract all sorts of is going to accept all sorts of difficultly formatted files, and it's just going to format it for you and return it, including like tables. Let's see what else it deals with. We'll read through this. This is the unstructured library, by the way. A few months back, they started their API. But again, if you enjoy my content, you can find all the videos. This website should be updated by now with the latest videos. So ecohive.live, you can find all my content. If you're a Patreon, you can find the code download links. You can read the descriptions. For example, we're going to talk about Instructor. If you're at this website and you're looking for a particular content, you can use the search Instructor. See, this is the original video I made. I made 2 videos on Instructor, and we'll talk more about it here. Also, check out CodeHive. CodeHive has 900 plus free Python, GPT-powered Python applications. Every time you go here, the ordering is random. So you can, so this one says Travel Wardrobe Designer. So this is just for you to have some ideas. Feel free to use them. You can just copy the code and experiment with it. You can also download all the 900 plus apps. It's currently $100 at my Patreon. Okay, let's take a look at unstructured. So I was pretty excited about it, but I never got a chance to use it. They do have an open source API. But what it is 80% of enterprise data exists in difficult to use formats like HTML, PDF. But even non-enterprise stuff, right? Includes a lot of PDFs, such as the app that I built, right? LLM, large language model papers, which summarizes this app I built summarizes large language model related papers that are published in archive repository every hour. But if you click on these, you'll go there, and each one of these are actually PDF file. I was using PyPDF to extract this, but if at the time unstructured was available, maybe it would have been a better option. By the way, if you go to llmpapers.up.railway.app, you can actually download this app, modify it, and publish it yourself as well. This is available at Patreon. Okay, so pretty much it says, regardless of data complexity or storage location, unstructured efficiently extracts and transforms your data into a clean, consistent JSON reading, ready for chunking. Yeah, it does split it for you. Embeddings and integration into your vector database. R file transformation pipelines classify documents into logical elements, enabling efficient removal of irrelevant content and making it easy to employ the most advanced chunking strategies. This process ensures that LLM stays updated, understands your organization. Look, they have a free one. So you just sign up and they email you an API key. And then I put it in my environment variables. That's it. There's also a paid version, but then it's hosted at AWS or Azure, but this is what I'm using, and it's free. Once you have that, they also have an API documentation. So once you go to their documentation, you go to Unstructured API, Python and JavaScript SDK, You pip install this. And then this is it. This is the simple usage. I modified how I deal with that. So, but if you take a look at it, you get this response, and response has elements in it. That's it. And you can print them, do whatever you like with them. Here in this case, I just saved them to a JSON file. So let's run this. It's very quick too. You can see it running. So I'm going to click run now, and let's see how long it takes for that JSON to appear. It takes about 4 or 5 seconds. Let's see. Okay, well, this is the longest it took, but here it is. I guess it can take up to 7, 8, 10 seconds. So when I tried this, it took anywhere from 3 to 4 seconds to 5. This time it took 8, 9. So I guess depending on how busy it is, it can take long. But once you have it, you have it. See, this is the PDF. I wish we could read this. So this is a large language model paper, pretty much. And it just broke it into these chunks. And I save them here like that as a list. See, this is the synopsis and the rest of the stuff. It tries to categorize it. It says this is narrative text. It has some metadata, language, start index. Yeah, so it does all this for you. And it does it very easily. So you just call the API. So you just get your API key. I'm getting it from my environment variables, but you can also set up a .env file. Put your key here. When you sign up for the free API key, they email you a single key. That's it. I don't know if you can replenish that key, change it up. So the key should remain secure, I suppose. I don't know if you can renew it, but once you have it, you can either put it here or your environment variables. And if you need to pip install load.env if you want to load it from your .env file. Okay, then, so I'll open it. Yeah, we'll open the PDF so we can compare. But let's talk about this real quick. If you wanted to load your API key from a .env file, put it right here. And pip install .env and import load.env, run it, and then get env. Now we'll get your API key. This has to match whatever is here. But if you didn't want to deal with it, just put it in your environment variables in your system by going to your environment variables and clicking here. That's it. And then give your file name. Open it, and then we call it. It supports single file at a time. It has different strategies. We'll take a look at that. And then, so you receive a response, and then response has elements. And I'm just dumping it to a JSON file. This is how it looks. Let's see. Dennis in the chat wanted to see how accurate it is. So let's see. So this is the first text, 322. I'm not sure where it's getting that from. Next one is LCSC. Oh, see, it's getting these side stuff. Next one is the date and stuff. Next one is the title, and it says title. Simul LLM, a framework for exploring high quality simultaneous translation with large language models. Next one is the authors. Victor Agostinelli, Max Wild, Matthew Raffel, Kazi Ahmed, Asif Fouad, and Lizo Shan. Oregon State University, and it even got the curly brackets right. Agustin V. So it seems like you got everything all right. For case, Chen Liz at oregonstate.edu. Then it says title and an abstract. Then it says narrative text, and this is the abstract here. Try to zoom in more. I'm not going to go through it all, but this is how it works. It seems pretty good. Yeah, I'm just looking at the last. So this is how it works. It's nice. And let's look at the beginning of the next. Focuses. Narrative text. Oh. Okay, this is problematic though, isn't it? Look at that. It's the next one. So this was the abstract. And then it should continue here, but it continued from here. Focuses. Okay, good thing we noticed this. But maybe there's this is related to the settings because it says strategy fast. Let's see what other strategies they have. So they have a JavaScript as well. I believe we need to go to API parameters strategy. The description, strategies. The strategy used for partitioning PDF image. So it does deal with images. So that's the good part. It deals with tables then and images. Options are fast, high res. So we need to try high res, I guess. But I don't know if this is going to make a difference. Output format. Coordinates. Include page breaks. If true, the output will include page breaks. PDF inferred table structs. These are all the arguments you can use with it. Skip inferred table types. Chunking strategy. By title. Multi-page selection. Combine under n cars. New after n characters. Max characters. Because you can set a mix chunk. This PDF, does it have a table? I guess so. Would this be considered a table? It's an image, right? It does have this table. Let's take a look at that too, but let's first test if high res makes a difference. Plus, we'll see how long it takes. Let's run it again. It is taking longer. Okay, well, while we're waiting, again, I'd like to talk about this polling app. It's very cool. You can ask any question you like. For example, what is the best backend framework or web app? Let's say for Python. And then you can enter your options here. Fast API, Flask, Django. And then you can run the poll. It's going to vote for Django. Second one is Fast API. And then shortly thereafter, it'll summarize the reasons why it was voted that way. It should anyway. But if you were to ask what is the best backend framework for Python for real-time applications, Yeah, now it's selecting fast API. That's what I'm realizing. I'm learning Django. This was built with Django. Yeah, see, it summarizes. The personas consistently advocate for fast API as the best choice for real-time applications in Python. They highlight its high performance asynchronous capabilities. That's it. So Django is amazing. Hey, Javier. It works. I mean, that's a bit of a secret, but it just pretty much it pulls stuff for you. That's the idea. You can add up to 5 options. Try it out. Let me know what you think. Let's see if this is done. Yes. And it is better. I can already tell. And it also said header. Okay, let's compare. So remember, this is all this stuff, I think. Header. Okay, what we need is title. We have the authors. And we have the abstract. And after that, again, it goes to this side. So I don't know why this happened. So this must be they must have a solution for this. But let's try to find, so you can search for a page number. So this is page 1. This is still page 1, modern language model. So it went like this. It went this abstract first, then it did this part, and it did this part. And I think it's going to do this part next. Yeah, while LLMs. So it did 1, 2, 3, 4. Then it's going to move on to the second page. Let's see if it did that. Yeah, page number 2. Tentatively, okay. So if that's the case, we can look. See, we can look at this table. This is on page number 3. Let's go to page 3. Oh, page 3. Yeah, look at that. Target English output the mechanics. Target English output. That's what it says here. Oh. And then the mechanics have repaired the car's accelerator. The mechanics have repaired the car's accelerator. German input. The mechanic have the Mechaniker haben das. So it has these have repaired. So it has this part. Figure 1. So it has this, but it didn't say anything about model output. So it skipped that part. But you know what? I've noticed this when, so I had this long time ago, like almost like maybe more than 6 months ago. I did do how to install Unstructured for LangChain, and it was quite the task. You had to install, I think, what was it? The Facebook's what is it? Perceptron? Like no, I forgot. But the image recognition modules and all of that, and then that's kind of like an OCR, right? But it can recognize images, read from images, also recognize tables, and the same problem existed then too. So then I'm assuming they may have improved it, but at the end of the day, maybe because this installation was so difficult, and as a matter of fact, this particular installation instructions actually is missing one part because one of the URLs no longer exists. So this, because it was so difficult, I think what they were trying to do with this API is just to maybe have the same thing, but much easier. That's what I'm thinking. So there's an unstructured GitHub. It should be right here. They mention it somewhere, but you can try to install this locally and do all of this. Obviously, also maybe they run on a faster machine because all of this takes time, right? See, open source library for custom pre-processing pipelines. So this is difficult to install. That's why they have a Docker now and all that. But it's, it's not perfect, I guess then. So I mean, we just saw that it's not perfect, but it's very convenient. If you dealt with unstructured before, believe me, this is like 10 times more convenient. But I guess it's the same thing as the library, I suppose. Let's see, when was this updated? 3 weeks, 2 weeks ago. So I guess they go hand in hand, is my guess. But just to be able to call an API and get all your information seems nice. But as we see, it is the same. Let's see if we got this image. Okay, the next page, we need to go to page 4. Okay, here we go. See, page 4 has this equation, and there's an equation here. And then chunk-wise variations, it's this text right here. And then it has the next one. And then it continues to fine tuning. So it seems like it actually parsing the 4th page correctly. See, it's 3.1. Okay, LLM support. Yeah, it's doing this in order. Fine tuning. Simul ML wrapper prompt. Yeah, right. Look at that. This is the image. Fine-tuning Simul MT wrapper. Prompt constructor. High-level large specs. It doesn't have the and hyperparams. And then it says, oh, it does. Sorry. And language hyperparams. So it made a mistake. It got and then language from here, and then hyperparams. Model, it got the model right from here. Yeah. PFD checkpoint. So it got PFD, and then it got this part. Supervised fine tuning. Trainer object, it got this. So I mean, my impression is that it's not perfect, it's not ordered, but at least it's reading it somewhat. Yeah, and that was the experience using the repo anyway. Unstructured, yeah. It was that's difficult. Reading PDFs in a business on its own. I've talked to companies about doing this. Yeah. That's right. I think that's why they did this. I think they weren't trying to make millions or anything at first. It just was so difficult to install, and they probably just said, "Why don't we just make an API and also offer it as a service?" They're nice. Look, they have a free one. This code runs the free one, but I guess if you have a lot of documents, then you can get the enterprise version. Okay. So that's all about unstructured. Like I said, there's a bunch of parameters you may want to play with. High res works better than, I suppose, fast, obviously. And that's it. But make sure or know, where was it? They have, okay, documentation. Unstructured API. Look at the parameters, right? It has a bunch of different coordinates. Maybe it says coordinates is false. Maybe if you already know the coordinates, you can order it yourself. Just take a look at these. All right. Next up is the instructor. So Instructor is great, and I think I'm going to make a new section of it in the Everything GPT API course, or sometimes I call it the Masterclass. But let me just talk about why this course is useful. I use it myself all the time because, so I started this. We don't need these. Let me delete these. So this is the course, right? So I started with older OpenAI library. And my idea was explain some stuff, write some basic code, explaining how everything works. And this one, at the end of the day, kind of covered like parameters. Like there's a lot of people know about temperature, but there's top P, and you can get actually, you can get chat completions to return multiple responses at the same time. Like a lot of, like, if you were to set n to 10, then the same call will return 10 responses for the same user message, same system message, and they're all going to be different one way or another, right? So n parameter is interesting. There's the stop tokens you can use. There's a really interesting use case for the stop tokens. What stop tokens are is you can insert a list within a list like tokens. This is a new line. So what this will do is the chat completion is generating tokens. If it tries to generate a new line token, then that completion will stop and it will return you right then and there. So stop tokens is pretty much stops the generation process. But Matt Schumer, I believe, of Hyperwrite, I follow him on Twitter. He also is the guy who posted the self-driving computer GitHub repo, right? The self-executing computer. He actually came up with a really great use case for the stop token. He said that we know that language models perform better if you give them a chain of thought ahead of time, like a reasoning, like some kind of thought process ahead of time, like step by step. Think before giving me an answer, think about it, right? But then the shortcoming with that is that's going to take time. It's going to take tokens. What he found out is that if you instruct, let's say GPT, to do the same step at the end, it's not as good as if you were to do it in the beginning, but it's better than if it doesn't do it at all, is what he found out. So then he figured, okay, so this is how you instruct the GPT then to say, well, let's demonstrate it real quick in the playground. I guess I'm jumping around a little bit, but I think that's fun, right? So we can instruct it, right? Answer user questions. Always think step by step ahead of answering. Perform the thinking process in between thought tags. Let's just say that. And then I'm going to say, what is Babel's library? Let's see what it does. Let's increase this. Let's go to GPT-4. Okay, so see, it's using these tags. See, it thought about it. You see that? And then it's answering. So we know this works. This is like pretty much chain of thought. All of that. Oh, it's answering it from a computer science perspective. That's not what Babel's library is a novel led by a Spanish author. Babel's library book. Let's ask that. It's a really interesting idea. Cancel. I have to delete these. Okay, but before we answer, right, we're going to say always think step by step after answering, right? That's it. We're gonna ask the same thing, but instead we're gonna ask it to do it at the end. So Babel's library, or more commonly known as Library of Babel, is not an actual book, but a concept from a short story by an Argentine author. Yeah, this is really interesting. Take a look at it. But look what's going to happen, right? So it's going to answer, going to go on. And see, it's doing the reasoning at the end, right? So the idea is you improve your response, but you save time, right? That's the idea. The beautiful thing is that you can even cut this out It's stop sequence. See, enter a sequence. I'm going to put this, and then you have to put tab. So now that I've added this stop sequence, which is the beginning of our thought process, if I were to ask this again, it should give as though it was going to reason at the end, so therefore improve the answer quality, but don't produce the reasoning because maybe we don't need it. Therefore, return the response to user quicker, plus save time and all of that. See, it stopped. Oh, it's going, but it stopped right now. So it didn't produce the reasoning because we have a stop sequence. So there's all kinds of useful parameters. There's presence penalty, frequency penalty, logit bias is interesting. But this is where I started building it. But then the new library came out, and then I switched to that. So this is organized in folders. They are, as I find things that I'm interested in, and I think they're fundamentally important, I put them here. This entire thing is available at Patreon. Link is in the description, but why this is useful, that I use it a lot, is that because it has files, and every file is a video. Sometimes I'm behind. I should make videos for the some of the files, but I'll always catch up. If you're a patron, then I'll update it, and you'll have access to it whenever it gets updated. But see, here's like a boilerplate call. You can just use it. Here's a streaming call. You can use that. Here's a JSON mode call. Here's one with seed parameter. Here's one with like function calling. Because I use this all the time. I use like I don't remember how the function definitions go all the time. I don't remember exactly how I enter this response format. So you'd have to go and find it from the documentation or something like that. So instead, because I built this, I always come here and take a look at it and grab stuff from here. And then it has complex examples, such as like this is with vision. It takes snapshots and gets a website described. This compares websites. This one narrates video. So I keep building on top of this at the end of the day. And I think Instructor is fundamental enough that it should go in here. I'll just quickly describe what Instructor does. I don't know if you've known about Pydantic, but Pydantic is like a typing library, type checking library, I guess validation library. You may have seen, like, when you're defining functions, you can say things like that. This specifies that this function takes in what's called data, but data can only be a string. If you try to pass integer here, then this will raise an error, right? But if you were to do it like this, data, then the data can be integer, string. It doesn't matter. You haven't set its type, right? Why is setting the type of variables is important? I think it's especially important with databases. It's especially important with web pages. For example, you can, if you have a website where you take in user email as an input, you have to verify that that's actually a correct email format. For example, you want to make sure that the user, whatever the user input is entered, has to match a certain criteria. They call it sanitization and all that. So without getting into so much detail, just know that it's very important. That's something I'm learning myself, especially if you build web apps more and more, that becomes important. That's why there's this library called Pydantic to do all this, right? So some group of people, open source, what have you, wrote this library called Pydantic, and with Pydantic, you define your classes of data types and stuff like that. Okay, and it offers you a bunch of stuff like enumeration and stuff like that. Right, like labels, like here label can be both spam or not spam, for example, and you can enumerate like that. So it'll make sure that it checks and make sure that it's written exactly like that. You can make sure you can do matching cases and all of that kind of good stuff. And because Pydantic is so powerful, the creator of Instructor, Jason Lear, just created a whole thing which patches OpenAI's library and then allows you to perform function calling directly from Pydantic data types at the end of the day, which makes things so much easier because all you have to learn is Pydantic, which is actually not as hard as it might look. It's much easier to write than a function schema in JSON, and it's easily understandable, and it's easily convertible to that JSON schema, and that's what Instructor library does in the background. Let me see. There's some messages in the chat. Oh, could you zip the repo and add this knowledge to the last assistant? Yeah, I guess you could do that. Yeah, I mean, does assistants accept zip files? I'm not sure. Actually, let's find out real quick. Assistants. I think it's at the bottom of tools. Supported files. Zip, yeah, it does accept zip. Oh, but not for retrieval. Yeah, CSV is still not supported for retrieval. Anyway, but you can put them into a single file, right? You could do that. Okay, going back to Instructor. So you can do this. I did change this a little bit. Let me make a new file. Actually, let's do this. Because what Instructor, so you can use Instructor in two ways. That's what, let me grab a simpler example. Instructor, GitHub. Let me grab this real quick and I'll explain the difference. So you do have to install Instructor. I'll make a requirements file here. We'll put these here. So you do have to pip install OpenAI Instructor. I think if you install pip install Instructor, it'll install the appropriate version of Pydantic and OpenAI. Just keep that in mind. So let's just see. Oh, in my last live stream, because we did talk about Instructor, I believe, or we were going to, I created a new Conda environment. So let me actually show you. So I'm in this, maybe this might be useful as well. When I started my command prompt, see, I started in my base environment. I have Miniconda installed. Okay, it's very easy. I like Miniconda for environment management. Just go to Miniconda, install it, restart. Make sure when you're installing it, add the path. Make sure you click the check mark that says add the path. And then restart your IDE. After that time, your environment, you should, when you launch your command prompt, you should see this type of stuff, which says base environment. And then I type conda activate new _n, and that activated the new environment. But now what I want to do is I want to deactivate it. You can say conda deactivate, but you do have to type it correctly. See, I went back to my base environment and Control-Shift-P. Let me look at my interpreters. Live stream. See, this is the one we created last live stream. So let me activate that. Conda activate live _stream. Steam. Okay. Always typos. Now we activated that environment. When you activate your environment in your terminal, that doesn't mean that it's active in your VS Code. Take a look at it. We're still in the new env. You can click here or do Control-Shift-P and then actually switch. So when you press play, your scripts will run from that environment. But the whole reason why I did this is to do pip show instructor to get the version of the instructor. And sadly, actually, I hadn't installed it there. So let's go ahead and install it. Pip install instructor. See, when instructor is installing, it's installing Pydantic and installing OpenAI. And then now we can say pip show instructor. Pip show instructor. 0.4.2. Let's add it here. Instructor. Yeah. So if you just install instructor, this whole thing should work. It should also install OpenAI and Pydantic, but we'll put them here anyway. Let's close these. Okay, so when you install, you import instructor, and then you import your OpenAI library like you normally would from OpenAI, import OpenAI, and then you apply this line. When you apply instructor.patch OpenAI, then it modifies the OpenAI library to perform all the good stuff that instructor does. In the second file, we're going to see you don't actually have to do that if you didn't want to. So then you define a user detail class with the base model from Pydantic, and essentially it's just like name and age, right? So what does this mean? We're going to have some content. This could have been a PDF, right? And like some PDF content. And then extract JSON is 25 years old. We don't even have to say extract, I believe. JSON is 25 years old. Because we've defined this class, user detail, you just enter response model. This parameter becomes available because we patched OpenAI library. Yeah, thank you, Chris. And we just say user detail, which is the name of the class. And then here we can print user. That's it. So this whole thing is going to make a function call. It's going to create the schema for you. It's going to extract the information, and it's going to return a Pydantic class, Pydantic object. With name and age. See, this is a Pydantic object, name, age. Because it's a Pydantic object, right? Just like OpenAI, this is Pydantic is what OpenAI returns anyway, so it makes sense. So we can say user.name. And if you run it, then it should now print JSON. See, we could have also said user.age. Now the cool thing is we can create a list of users. Yeah. So another cool thing is ChatGPT and Copilot is very good with Pydantic. Like Pydantic is super popular. Like I think it gets downloaded like 200,000 times a month or something. Like everybody uses it. So therefore, GPT knows a whole lot about it. So therefore, like if you don't even know your schema, you can just go and explain it to GPT. It'll give you a Pydantic schema, and then you can just print it and see if that matches. Okay, like it's so cool in my opinion. So what happened here is that we define the users, which is going to be a list of user detail. So users is a list which includes many user details, right? What does that mean? For example, let's say memo is 42. I don't know. Jessica is 30 and Mark is 88. So now let's print the user. Oh, okay, mistake. Our response model is now has to be users. And now if we run it, we should get a extracted list of all this stuff. See, users is a list of user detail objects, name, memo 42, Jessica 30, Mark 88. It's pretty awesome. Yeah, exactly. That's why, that's why function calling is good for, right? You don't have to use function calling to call functions, although you can. If you had a function, let's say, let's go back to the original. If you had a function, print name function, def print name, right? Print, yeah. So we need the name. So let's say we had something like this. Then now we can just call this function user.name. You see, this is how it would work. So now we are getting a response and then calling print name, print underscore name. We're calling this function with this username. It should say hello JSON. Yeah, so it's as easy as that. You define any kind of class in any structure you want, and then after that, you input any data, get your structured output, print it, save it to a file, save it to a database, or run a function with it. So this is what the Instructor is good for. So that's why it's like amazing. You can build on top of this stuff. There's, I would recommend, maybe we'll do it together. We still have some time, but Instructor has a really nice documentation. I read through the whole thing. Tips are great. Concepts are great. I went through all of this. Cookbook is great. Blog is also awesome. There's quite a lot of good stuff here. And it explains why it's important, why it works. And it's just, I think it's awesome. I think you won't lose anything by learning Pydantic and Instructor. I think it'll only add. So, but what if this is kind of too abstract and you're like, okay, but I don't even know what's going on. Streaming responses are a little difficult here. So therefore, you can actually have more control over it like this. So you pretty much do exactly the same thing, except instead of importing Instructor directly, you import this what's called OpenAI schema from Instructor. Now you don't have to patch the OpenAI library. You're going to use OpenAI library like you know how to use it, right? Nothing changes, except you still can define your Pydantic classes, right? And then you can have streaming true if you want it. Okay. Right. But what happens here, right? So how do we use this? Well, you use it like you normally would, right? In the new library, you define your tools as type functions. Like it's a list. It's a list of type functions. And here normally you would insert your JSON schema like this, right? This is your JSON schema. and where is it? See tools. You define your tools like this, right? Tool is a list. Type function, JSON, and function JSON is a schema. You'd have to normally define it one way or another. Here, you are using the class.openai schema. That's it. And then it'll insert the schema there for you. Except the only difference is you're also not using the base model anymore. You're using OpenAI schema. But OpenAI schema, yeah, I believe only has to go to the final class. So we define some labels, and then class label takes in labels. If you were to run this, like this is a test, it's gonna try to classify it as either spam or not spam. But now, you have your streaming responses and everything. Let's actually turn it on. Yeah, see, it returned the whole chat completion. Let's run this so we can see it being printed. Oh, let's comment this out and run it. An error occurred. I don't know why, maybe 11:06. I'm not sure why this is happening. Let's see, maybe the API is busy. It's not printing anything. Let's do this. Try accept. Classify the following text. Let's write something else. Call now. Operators are standing by. I tried this. This was working before. I don't know, maybe API status. Okay, you know what? Let's not do streaming then. We'll do it later. It was working before. Let's still use the 11:06. Print response. We do want to return the regular response. So how was the regular response? See, I don't know it right away. Basic chat. This is how we get it. Oh, this is the old library. New library, basics. Okay. Like that. Oh, yeah, I am making a mistake because this is a function call. Yeah, sorry. My bad. Oh, that's why this wasn't working. Okay. Yeah, I have to check for other things when function calling, right? what was it? Function args. Response message, response.choices. This is what we need. Let's grab this. Is this streaming? No. Okay. Return response. Right. And then like that. Yeah, this is what we need to do. And we don't need to, we're not going to call a function. So we're going to clean this up. So we get a response. Then we get the dot message. And then this one is a dot tool call. So we check the tool calls. It's going to have a tool call. You don't need available functions. Let's get rid of this. Yeah, if tool calls. Yeah, so why do we do a loop? Because we check if it's a tool call. Normally, right, we don't have to do it here, I believe, because it's gonna call a tool, most likely. But we check if it's a tool call, then we can loop over all the tool calls. This is the parallel function calling part, right? Now you can use you can call multiple functions in parallel with the new API. That's why we're looping, and we're gonna supposedly call all the functions. That's why we need to get the function name and function to call, but we don't need this right now. Well, because we're only using it for structured information. So let's get rid of that. We don't need the function name. What we need is the function args. We need JSON. Import JSON. So we're going to load JSON.load tool calls functions.arguments. Can just print that. And it's trying to call the function. We don't need that. Just print the function args. Okay. Now let's run it. Yeah, see, not spam. Function args is not spam. And it returned a class label because that's what we specified here. So see, we are printing function args and we're printing the object. I'm curious if this were to say call now, operators are standing by. Spam. So it classified as a spam, but this is all to say, okay, there's two different ways you can use Instructor. The easy, super quick way is to patch the OpenAI library, and then all you have to do is just the response model. You input the response model is as your Pydantic class name, right? User detail, for example. So this will take care of all of it for you. But if you wanted to have more control, including you can facilitate streaming responses with that, then you don't have to patch, but instead you import OpenAI schema from Instructor. And when you're defining your classes, instead of using base model, use OpenAI schema, and then you can generate function descriptions from Pydantic classes. Just like that. And then, but we did say then for the rest of the responses, you have to handle it yourself. Just as you would normally. So, you can have it two ways. There you go. Hello, Akko too. To you too. So this is the general idea, right? I'd recommend really read through this. Maybe I'll put this in the chat. if you want to bookmark it or something. It's really helpful. Let's just go over like general tips and then we'll end this live stream. But again, I do want to mention, if you want to find, I have over 200 videos. If you want to if you're searching for a particular subject, like let's say Instructor, you can go to my website, echohive.live. Just do a quick search. Find all the videos about Instructor. Or like AutoGen, for example, or LangChain. It makes it easy. You can read the descriptions here. These are YouTube videos. You can watch it right here or at YouTube. If you're a patron, you can also download the code files. Also check out the CodeHive beta at www.codehive.app. Make sure to put the W's in front. At CodeHive, you can access free 900 plus free Python applications, GPT applications. And you can just copy the code and test it out. You can also download all 900 apps for $100 at Patreon. And the thing that we were looking at is the masterclass. It's at Patreon as well. See, all the folders are zip files here. Just remember that. And as I update it, you'll have access to those as well. Yeah, see, all these folders are as zip files there. I do have to make videos for these. I'll update it, and I also for this one, which I will do soon. Anyway, let's just read over the instructor tips and then end this. And thank you all for joining anyway, ahead of time, ahead of ending it. The overarching theme of using Instructor and Pydantic for function calling is to make the models as self-descriptive, modular, and flexible as possible, while maintaining data integrity and ease of use. Modularity: design self-contained components for reuse. Self-description: use Pydantic's field for clear field descriptions. Yeah, that's right. For example, you can have fields. I forgot how they go. You have to first import it from import field. Import field from Pydantic. Yeah, you import field, and then you can have field descriptions like this. ... means it's required, I believe. And this description literally is the description which you have written in your JSON schema. Let's take a look. Function calling. If you were writing your schema, right, you have your parameters, like this is of location is of type string and description. You can insert these descriptions like this. Okay. Also, I forgot to mention, when you're defining your Pydantic classes, the doc string that you write is also added into the description. Okay, so you can use all this additional places where you to add additional information. And since this is going to get converted into a function definition, then rest assured, GPT will know about it. So all of these give you a chance at prompt engineering, pretty much. Optionality: use Python's optional type for nullable fields and set sensible defaults. So optional, right, is not for non-required fields. Standardization: employ enumerations for fields with a fixed set of values, as we've done with spam and not spam. Right here, so we are using enumeration, so it knows exactly what to return. Because labels is of type of enumerating either spam or not spam. Dynamic data: use key value pairs for arbitrary properties and limit list lengths. Entity relationships: define explicit identifiers and relationship fields. Contextual logic: optionally add a chain of thought field and reusable components. See, just like this modular chain of thought. See, from Pydantic, import base model field, class role, and it's just defining a chain of thought variable with the field. Think step by step, determine correct title. So it's a string. So it's first going to return some string, which is going to be chain of thought. Then it will return the title. And the instructions is think step by step to determine the correct title, and we insert it as a field. And then user detail is going to be age, name, and the role is going to be this class right here. Utilize optional attributes, use Python's optional type, and set a default value to prevent undesired defaults like empty strings. So here we're defining age is going to be integer, name is going to be string, role is optional, and with using the field, you can set default to none. Right? So therefore, normally, right, if there is no role, usually because you've specified it, the role has to be returned with the function called, and you'll get an empty string, but then here you can set defaults, is what it's saying. Handling errors within function calls. This is really super awesome. You can create a wrapper class to hold either the result of the operation or an error message. This allows you to remain within the function call even if an error occurs, facilitate better error handling without breaking the code flow. So here, see, what do we do? Self.result. So we do say result has to be none. Well, sorry, if it, so we're going to return, I believe what this means is return self.results. So I'm still also learning Pydantic, but what I wish the examples are more self-explanatory. We can actually give this to GPT to explain it, but the idea with handling errors is the fact that you can check if a particular variable is like the way that you defined it or something like that, and do error handling with additional methods. And then you can also do validation, and then you can actually get an error message. Let's say if the first letter of the name is not capitalized, you can actually get an error message returned to you. Literally as you describe, and then you can actually return that back to the model. That's why actually perhaps let me show you. There should be an example here. Well, let's continue. Maybe there's one here. Because Instructor also, when you patch it, Instructor also comes with a parameter that's called retry. So if you don't get the exact structure that you're looking for, then you can actually get an exact error from using Pydantic, and then you can send that error message back to Instructor. Automatically sends it back, and then therefore allows the GPT to be able to correct itself. And you can set max retries. Simplification with maybe pattern. This is interesting. You can, so these are a bit abstract, but once you get it, I think it really simplifies stuff. You can further simplify this using Instructor to create the maybe pattern dynamically from any base model. And then here it says, so if you import Instructor has this maybe. Right, user detail. This allows you to quickly create a maybe class for any type, streamlining the process. I guess so. This is like whether when you're checking something, it can either be true or false, or it could be somewhere in the middle. I guess this allows you to check for that. Tips for enumerations. To prevent data misalignment, use enums for standardized fields. Always include. And other option is fallback, so the model can signal uncertainty. Right, so this is essentially saying if you set the enumerations, then you're, instead of saying, well, like role can be principal, teacher, student, you'd have to say that to GPT one way or another, right, in your instructions. Therefore, Pydantic along with Instructor is going to do that for you. But here's another good tip. Always include other option, just in case if the data that you're trying to extract doesn't fit into any one of these categories, you're allowing GPT to refer to other rather than hallucinating. And here it's entering a description. If you're having a hard time with Enum, alternative is to use literal, so you can actually instead use the literal to give it options. Because these can get, pretty abstract, so it's offering another option. Reiterate long instructions. For complex attributes, it helps to reiterate instructions in the field's description. So when it's defining this role Pydantic model, it has first of all, it has a docstring, extract the role based on the following rules, and then it has an instructions variable, which is going to be a string, and it gives a description field, which says restate the instructions and rules to correctly determine the title. Essentially, you would insert your instructions here. So you tell the model to follow the rules. Maybe you insert your rules here, plus you can add instructions here. I suppose this is allowing the model to restate the instructions, right? Sometimes it's like, let's review the process, and then it's kind of like, let's review. Like you give a bunch of instructions to GPT and then you allow it to review the instructions before acting on them, something like that. It's like a little trick. Handle arbitrary properties. When you need to extract undefined attributes, use a list key value pair. So essentially, you just say there's a property you want to extract, right? And you just say key value. That's it. And then you say the properties are going to be list of the type property. So you don't know what they are, right? But then here's some description. Extract any other properties that might be relevant. So it'll automatically create key and value pairs. Limiting the length of lists. When dealing with lists of attributes, especially arbitrary properties, it's crucial to manage the length. You can use prompting and enumeration to limit the list length, ensuring a manageable set of properties. You can use prompting and enumeration. Oh yeah, I see. So it's giving it an index, monotonically increasing ID. And then here in properties, it's adding a description, numbered list of arbitrarily extracted properties. And it's saying should be less than 6. So this is really interesting, right? Pydantic is very programmatic, very strict, but then you are using this natural language to interact, create this mixed attitude towards prompt engineering, right? You're combining natural language with some very strict typesetting and stuff like that. Very cool. It takes a moment to get, your bearings straight with this, but once you do, you realize, wow, makes things a lot easier. Using but I still use JSON mode and stuff too, right? It's good to know everything. JSON mode is very clear, quickly describing things. Where is it? Right here. You can still use JSON mode, but you have to really explain yourself here and give. Normally, this should include an example JSON schema and stuff, and you have to type it out all yourself. As long as you have to type something out, might as well do this. And another thing I just wanted to tell you is, if you go to ChatGPT, it's very good with this type of stuff. Give me Pydantic classes to organize a scientific paper, which is a PDF. I don't know. Let's see. So it's very good. You can just ask GPT. Let's see if it's going to do it. Yeah, see? So it's creating an author, name, affiliation, email, section, reference, figure, table, scientific paper. So you can let GPT create these for you very easily. Okay. Using tuples for simple types, it's saying you can use a tuple. Advanced arbitrary properties. For multiple users, aim to use consistent key names when extracting properties. Extracting information for multiple users, use consistent key names for properties. Defining relationship between entities. I do have to go soon, that's why I'm rushing a little bit. Reusing components with different contexts. And for example, you define a time range, and you can use it for both work time and leisure time here. So yeah, it's really interesting. Just take a look. That's about it. And I would really like your feedback on the Ask AI people. It's a polling app to get ideas for all sorts of things. It's a polling app essentially. It uses AI demographics, and it's accessible at www.askaipeople.com. Make sure to put W's in front of it till I fix that situation. Well, thank you for watching. I hope this was helpful, and see you in the next video. Take care, everybody. Thank you for being here.